Have you ever looked at a fan, a washing machine, an electric car, or even a small toy car and wondered, how does electricity become movement? That is the basic magic behind an electric motor. In this video, we will start from zero. No complicated formulas, no advanced electronics. Just the first simple idea. An electric motor is a machine that converts electrical energy into mechanical movement. In simpler words, electricity goes in, rotation comes out. Let's understand how. Before motors, if humans wanted movement, they needed something physical to create it. For example, a human pushes something, an animal pulls something, steam pushes a piston, fuel burns inside an engine. But with an electric motor, we can use electricity to create movement directly. This is why motors are everywhere. They are inside fans, pumps, washing machines, electric windows in cars, elevators, hard drives, drones, robots, factory machines, and electric vehicles. Anytime you see something moving automatically, there is a good chance a motor is involved. A motor is a device that turns energy into motion. But an electric motor specifically uses electrical energy. So the simple chain is electrical energy creates a magnetic effect, and that magnetic effect creates mechanical movement. That middle part is very important. The motor does not spin because electricity is magical. It spins because electricity can create magnetism. And magnetism can create force, and force can create motion. So the real secret of motors is not just electricity. The real secret is magnetism. Let's imagine two magnets. If the north side of one magnet faces the north side of another magnet, they push away from each other. If the north side faces the south side, they pull toward each other. So magnets can push and pull without touching. This invisible pushing and pulling is called magnetic force. Now here is the important idea. If we can control magnetic force, we can use it to create movement. That is exactly what a motor does. A motor uses magnetic forces in a controlled way to create rotation. Now we add the second idea. When electric current flows through a wire, it creates a magnetic field around the wire. That means a wire carrying current behaves a little bit like a magnet. And if we wrap the wire into many loops, we create something called a coil. This coil becomes much stronger magnetically. So now we have a very useful trick. By sending current through a coil, we can create an electromagnet. An electromagnet is a magnet that can be turned on and off using electricity. This is one of the most important ideas in electric motors. A normal magnet is always magnetic, but an electromagnet can be controlled. Turn the current on, use, and it becomes magnetic. Turn the current off, and the magnetic effect disappears. Change the direction of the current, and the north and south sides can switch. And this gives us control. And control is what allows us to create rotation. Now imagine we place a coil between magnets. When current flows through the coil becomes an electromagnet. One side of the coil is pushed, the other side is pulled. This creates a turning force. That turning force is called torque. Torque is simply the force that makes something rotate. For example, when you open a door, you apply torque. When you use a wrench to turn a bolt, you apply torque. In a motor, magnetic forces create torque, and torque makes the motor shaft spin. So the simplified idea is, current flows through a coil. The coil becomes magnetic. Magnets push and pull the coil. The coil starts rotating. The shaft turns. That is the heart of a motor. But now we have a very important question. Why does it keep spinning? If the coil turns only once, it may stop, so the motor needs a way to keep changing the magnetic direction at the right time. In simple DC motors, this is done using something called a commutator and brushes. Their job is to switch the current direction as the motor rotates. This keeps the magnetic push and pull happening again and again. So instead of moving once and stopping, the motor continues spinning. In other types of motors, this switching is done electronically. For example, in brushless DC motors, the electronics decide when to energize each coil. But we do not need to go deep into that today. For now, remember this. A motor keeps spinning because the magnetic forces are controlled and repeated at the right time. At the beginner level, you can think of a motor as having three main ideas. First, something stationary. This is the part that does not move. It is often called the stator. Second, something rotating. This is the part that spins. It is often called the rotor. Third, magnetic interaction. The stator and rotor interact using magnetic fields, and this interaction creates motion. So when you hear words like stator and rotor, do not panic. Stator means the part that stays still. Rotor means the part that rotates. That's it. Think about a motor like this. You are trying to spin a wheel. Instead of touching it with your hand, you use invisible magnetic pushes and pulls. But you do not push randomly. You push at the right time again and again. That repeated timed push keeps the wheel rotating. This is what happens inside a motor, but very fast and very precisely. So today, we learned the first principle of electric motors. A motor converts electrical energy into mechanical movement. The bridge between electricity and movement is magnetism. Electric current creates magnetic fields. Magnetic fields create force. Force creates torque. And torque creates rotation. In the next video, we will go one step deeper and answer a very simple question. What is inside a basic DC motor? We will look at the rotor, stator, coil, magnets, brushes, and commutator, slowly, one by one. Thanks for watching, and see you in the next video.